Today, Fabio and I are going to be presenting a project that we've been working now for over a year and a half, it's this Excel Python bridge that that we mentioned. So I'm going to be giving the overview and the examples, use case examples part, and then Fabio is going to be doing like more in depth of the features and the architecture on how we built this product. So the first thing that we came up with, like, what are we trying to solve? And kind of like when we started this, it's like, how can we increase the impact of data science at large organizations, the companies that we're working with? And we kind of like started looking and seeing, okay, how many data scientists are in the world? And we looked at some survey that the Jupyter team did, and they kind of estimated the Jupyter user base to like between 3 and 6 million users. And then we like started looking also then like, okay, who else in the organization can be empowered with using data science? And we looked at a lot of people that have been doing data analysis for a long time, those data analysts, business analysts at different companies. And we kind of like started looking at how can we, kind of size that market. And we took a look at like the most popular tool throughout that user base was actually Microsoft Excel. And Microsoft Excel has like an estimated 100 times more users than Jupyter. And so we came out with like that, if we can empower those Excel users to leverage all the things that are happening in the data science ecosystem, then we can help organizations increase the impact that that's having throughout them. So we started exploring what are the different capabilities and the different skills and the ways they think about data between those data scientists and the business analysts. So data scientists, use Python, use things like Hadoop and Spark. Jupyter is a very popular tool among data scientists. They think about data in like terms of pandas data frames or NumPy arrays. They think about machine learning models, and they kind of deliver notebooks and code and interactive visualizations. When we took a deeper look on like what business analysts usually use and how they think about data and what they deliver, we saw that they frequently used Excel, tools like Tableau and SQL. And they really thought about data like their spreadsheets, database tables, and they kind of delivered those like reports and spreadsheets and kind of like interactive dashboards. So we kind of like realized how that this business analysts were being left out of the data science revolution that is kind of like like represented in the Jupyter ecosystem, and like overall on the PyData one. And so we're seeing like there's this kind of disconnect. There's all these great tools that are happening in the open source, but are not really accessible to your average Excel user. So we thought that we would create this product that would connect the two worlds and be a bridge between those Excel users and those data scientists doing data exploration, machine learning models, exploring with big data and Hadoop and Spark, and doing advanced statistics in Python and Jupyter notebooks. And so that's when we started with this idea that we called Anaconda Fusion. And kind of like the base principle is that we want to make sure that everyone keeps using their preferred tools. So a lot of people like empowering people that don't know how to code and teach them how to code. That's a great idea, but it's also important to like meet them where they are. So kind of the base principles of designing this product is the business analysts are going to be using Excel, and data scientists are going to be using Jupyter notebooks. How do we bring those two worlds together? And like another part of that is how we can also leverage all this like Hadoop and Spark infrastructure that has been set up in a lot of large organizations. How do we make also those business analysts, that people that don't know how to code, leverage that technology that's already been set up and that like companies have already invested large amounts of money on it. So basically, it also should not also just connect to like a plain Jupyter notebook, but also have a larger access to this ecosystem of distributed computing. So that's part of also this idea of self-service big data analytics. And so we go back to what's the experience between this business analyst and this data scientist. We also wanted to make sure that it was seamless for both of them. So for this business analyst that's inside Excel, they get this Excel add-on that we call Anaconda Fusion. And it's a panel that comes up in your Excel spreadsheet. And basically, the process to do data science without using any code is they upload a notebook or they connect to one. In this case, this is the standalone version where someone shares a notebook with you. You upload this notebook to this add-on, and then you get all these different functions that exist in the notebook. You can select what function you want to run. And then depending on what function you select, you get a different type of inputs that's defined by the function that is in the notebook. And then they can also select the input that can come either from the Excel spreadsheet itself, or they can manually input it in the box. And then they hit run, and things happen. Either visualizations appear in the add-on, or data gets pulled back into the Excel spreadsheet. So this is the basic experience for the business analyst. We also wanted to make it very easy for data scientists to be able to create this customized experiences in the business analyst world. So it should also be very simple for data scientists to use this technology. So basically, we define just as one line of code, one decorator that you put into your function, and that's it. So once you register that function with Fusion, it takes care of all the rest of rendering the right functions in the Excel add-on, and also the right inputs and the right types, and takes care of moving the types from Excel to Python and the other way. So there's many use cases of this technology, like from allowing business analysts to directly extract data from databases inside Excel, optimizing, instead of doing manual SQL in one place, copying data over, saving CSV files, just doing everything inside Excel. Also empowering them to do machine learning models, or use the ones that data scientists are creating for them, kind of self-serve. The other one is extending the Excel capabilities around visualization and empowering business analysts to create more interactive visualizations, more complex graphs than what Excel allows you to do. And then, of course, this connectivity to big data that's right now kind of very hard and inaccessible to them. So I'm going to show 3 different examples. One is about running queries, which is something that business analysts are already very familiar with doing. The next one is on machine learning models, and a little bit how they're going to be able to self-serve in that space and do some exploration on their own. And the other one is running big data analytics connecting to a Spark cluster. So this first one is a query. So basically you input an SQL query, you click run and get data back into your Excel spreadsheet. So pretty straightforward. In this case, we're using the Lanham database data set. I don't know if people are here familiar with it. It's a baseball one, so you can select what are the minimal, average, maximum batting for a season. You can also get salaries of players, so you can query the sum of all their salaries and kind of order it from minimal to maximal salary per baseball player, get their top salaries, and things like that. So this is an example that business analysts kind of get immediately, because that's a workflow they are familiar with. So once we've set up this context, we show them what else would this tool empower them to do. In this case is running a machine learning models. So in this case, the function is called clustering. So they see it there. It's a drop-down function. If they wanted to perform a different modeling, they could select a different function there. And then you see inputs have data, which can be defined from the Excel spreadsheet itself. We have 2 data sets. One is called noisy circles, the other one blob. And then they have a number of what algorithm they want to use, and then the number of clusters that they want to group their data for this clustering modeling exercise. So let's take a look. In this case, when you click, just put the defaults, click run, and you get this visualization on how things are grouped. You can customize the number of clusters. I say okay, now I only want 2. It's still not grouping it in the right way, so I can select a different algorithm. I click it, and now, okay, it has grouped the things the way I want them. And at the same time, I'm getting the results back into my Excel spreadsheet. So this is really empowering the business analysts, even if they really don't know what they're doing with those clustering algorithms. At least they're seeing the result, and they can kind of like iterate. And it's like they can also change the data set in the data input. The final example that I wanted to show is one that connects to a Spark cluster and uses the Reddit data set. So it allows the Excel user to input a subreddit, do word counts, and get a plot of the words that are being used in that subreddit, all within Excel. So in this case, it's a Spark notebook. You can input, in this case, we'll do like the movie subreddit. You click run, and it goes back, runs that distributed cluster, and then comes back with the frequency of the words that it has counted, and also this word cloud plot that otherwise would not be able to create in Microsoft Excel. And they can paste the results back so that they can save that and share it with other people. So with that, I'll pass it to Fabio to talk more details of the features that it provides, and also the architecture on how we leverage the Jupyter technology to build this bridge. Thank you.
Thank you. Thank you, Christine. Yeah. So before going ahead, I just want to check how many of you would feel more in the business analyst side as their daily job today? 4 shy, 1.
What?
5. Right. Yeah. Yeah. Well, many times people are in between. It's true. So business analysts are mostly people that are working on data and trying to figure out things out of they care more about the business results. Data scientists are the people that make it happen using tools like notebooks or other technologies to get there. So how many of you work doing data science mostly? Okay. Okay, how many of you use notebooks as their everyday tool? And how many of you use Excel? Okay, cool. A couple of notes on the examples. Fusion Fusion itself, it has 2 components, as we can see. The component that lives on the notebook analyzes the functions and see the inputs and everything, and generates the UI for Excel. And the Excel user would just they get the widgets and everything on the client side based on data types and other things. So the whole idea is really to keep people on their preferred environment so they can keep working and caring about what they care most. Just a couple of more examples about the outputs that we can generate on the Excel side. This example is the feature that we have that instead of using the UI itself, users can still go and use their the formula bar. So in this case, I select a notebook, and they get access to the functions that were exposed on this notebook, just like they would do in Excel. And they get results back, the graphics on that side. Okay. So in this case, basically what's happening is users, are writing on the formula bar that calls a function in a Jupyter notebook kernel somewhere. It executes the function, getting basically the Excel data as input, and it returns back the results. If it's data, it's being written on the spreadsheet. If it's the graphics, it's being written also only on the UI part. This other part is an example of writing back to Excel. We kind of already saw that in the last example. But we can also tell Excel Fusion where to write by default, so it doesn't overlap with stuff on the current selection. And it also supports bokeh plots and other interactive plots. So in this case, we show a famous graphic of an evolution over some years. And you can interact with the plots inside Excel. Last one is other kind of plots that you can actually generate within the UI and then copy back to Excel spreadsheet. And those can be basically saved with the spreadsheet itself and be shipped. Okay, so as you can see, it supports pretty much everything that is supported on notebooks. The interactions with Excel are limited somehow for a few things like interactive plots. They cannot be copied yet and stuff like this, mostly because of technology limits. But everything that basically works on a notebook should also work within Fusion. We started this project basically to fill the gap between data scientists and business analysts. And the current solutions for this kind of problem are very limited. And we picked Jupyter as a whole platform to work on, mostly because the technology is really great already. The current solutions, they do not, they are very limited in what you can do, and they're very limited in getting the Excel users to work with something, because they need Python installation, other programming language knowledge that Excel users are very hard to get into. So basically, one thing that we like a lot in Jupyter land, let's say, is that it fills the gap between domain-specific users like scientists and computer software, and we want to leverage on that. Open source is a big plus for working on Jupyter as a platform. Open source is like driving the world right now, and it's getting bigger and bigger. Jupyter is a very mature and has a long history. Before it was cool, and before it was, even a notebook itself. The diversity in terms of the project, in terms of like projects inside Jupyter, is impressive, and also the amount of contributors that works actively on the project is huge. So you can take advantage of all that, and also the vision and the openness of the project, the community, and even things that are ongoing changes, big changes. They always are very open, and there's a really good timeline for things, and that's very important too, especially when you consider doing enterprise software using open source. Most of the problems with enterprise and open source are deadlines, or when things are getting out of beta or alpha versions, all those things. And being able to have a clear path and communicate with people working on things is very important. And also defining scopes where parts of something that is changing are stable and other parts are not. So being But in the meanwhile, the overall project is considered not 1.0. That's very important. And popularity is very important as well. Jupyter is the major technology for notebooks and sharing and interactive sessions and executing out of the box. It's not going anywhere, so it's worth considering as a platform to work on. For us, it was a very good experience. You can find a lot of good things inside the Jupyter ecosystem. If you just check the repo, those organizations on GitHub, you see a lot of repos with stuff that you can just use out of the box, and they solve a lot of big problems already. I already said that there's a great community and support, both inside GitHub and outside. And one thing to consider is also it's cutting-edge technology, especially if you consider using things that are coming soon with Jupyter Lab. And that's very good in one side, because you use like the best that you can get out around and things that are really innovative. But on the other side, if you consider enterprise context, that's very scary for an enterprise too. So that's another thing that you need to consider. APIs may change in the meanwhile while you're developing. And if you don't work considering those things, it might be painful. And another very good thing is that the whole Jupyter ecosystem is very pluggable. For us, it's perfect in the sense that we can just use the pieces that we want. We don't need to bring in a lot of stuff, and we can bring more while pieces are getting more stable. And that's what we did with Fusion, especially in a use case like this, where if you go to Stack Overflow and ask a question like about why I can't get machine learning inside Excel or stuff, or how do I do things with pandas in Excel, you get a lot of answers like, you shouldn't be doing machine learning inside Excel, that's wrong. But the real problem is that people need that. And if you have something that is pluggable, that you can just plug your Excel users in, that's very important. So taking a look real quick at Fusion standalone architecture as a product. It basically is an Excel plugin. Well, it has an Excel plugin component that lives inside Excel. And there's a Fusion server that basically just supports that. And it's a bridge that tells Excel where to look for notebooks, notebook servers. And then Fusion connects to notebook servers, check notebooks that have been published or exposed to Fusion itself. And then when a user selects that notebook, it spawns a session with the notebook server. And then basically everything else is just like you are used to do in your notebook with a different UI. So sessions and kernels are shared between notebook and Excel. And Excel users can run the same functions that that notebook user is running on their notebook interface. Fusion is kind of, there's an evolution of the product where we are shipping a version soon with our platform where this whole concept is a bit more general. We want users to basically be able to connect and use the data, use their models and everything from everywhere. So Fusion in Excel is just one of the clients of this whole API. So we're extending the concept to an API, and basically using the same groundwork to connect. Users would be able to write their own APIs for own apps that use Fusion API. from, I don't know, their legacy application or whatever client they want. In general, wait. In general, our experience working with Jupyter as a platform for new technology has been very, very, very good. We started evaluating 1 year ago, the whole application and everything. By the time Jupyter Lab was very different from what it is now. So we had to consider a lot of things, and we decided to go with more stable parts of the whole notebooks infrastructure and bring small pieces that have been declared stable enough when they were, while we were going. A couple of things that are necessary to consider since the beginning, I think, for anyone that wants to develop their own enterprise applications on top of this stack are users, licensing models, limitations, and stuff like this. And I guess that's it. Thank you. If you have questions, we have 5 minutes. Thank you very much.
Yeah. I had a question on so you had the Fusion.register decorator on your function initially.
Yeah.
And then I'm assuming like somewhere on the back end you're passing that to like the Jupyter server. You have a special plugin that basically runs it, goes on every function that you have and has this decorator and it registers that function on Fusion, this local Fusion client.
Yes. So there's no notebook plugin for that. It's just you.
On the server plugin.
There's no server plugin.
Okay, got it.
Yeah, there's only like a Excel plugin outside of Jupyter. When you import, you import Fusion, and then from Fusion you register, and that's enough for the Excel plugin to understand that those functions are exposed.
And then when you call out, so that assumes like this function is now in memory in your Python kernel.
Yes.
And then your, like, it's a JavaScript Excel plugin that calls out to the Fusion server and it says like these are the functions that have been registered. And it basically renders this form. And then when it goes to execute the function, it calls out to the local notebook web server that is then communicating with the kernel that has this in memory.
Yeah, somehow, sort of that. There are some more complications around type checking and you know.
Of course. So does that assume that in order to get this form right here, you have everything in memory within your kernel, or does it re-execute essentially like that notebook?
That's a good question. I would have said yes time ago. Now I would say no. It's not. You don't need to have executed before.
Oh, so it does not need to currently be in memory in order for it to appear right here?
Yes.
Got it. But then once this does execute, I'm assuming the entire notebook has to then execute and all of the variables that are in the global scope that may be referenced in that function need to exist, right?
The same answer. The thing is, the whole notebook is shared between, and that's pretty much like any.
Yeah, of course. Got it. Another question. So this is running locally on the host that Excel in Jupyter locally is running off of?
I think that use case, yes, but it doesn't need to.
Got it. If I wanted to then share this this function with somebody else on a different host, how is that built into Fusion right now?
Okay, so well, basically this is part of our platform. So our platform, this functionality is served from a platform itself. So it understands who is sharing what with others, and it can spawn the right things.
Got it. So like if I wanted somebody else to open up an Excel workbook and then make the same call that I did on their machine, would they need to have that notebook locally downloaded on their machine and host it locally on their own machine?
So it's we have kind of like two models. So like the first one is what we call the standalone model. It was the first architecture diagram, and this is like this use case. So you would send them the notebook, and they can like that's the first step. They upload the notebook there when like so they put it into like the Excel, and then they execute it. But that's run in their own laptop. And then we have ways to like specify what environment you were running when you were executing the notebook. So then we make sure that you're running the same environment, and then everyone is like running it in their own laptop, right? But Fusion and Anaconda take care of like making sure that the environment is the same so that you get the same results. The other architecture diagram, the one which connects to like a larger platform, then that doesn't have to like that. Movement of like a file does not have to happen because everyone's connected to the same platform. So that would be architecture number 2. That's connected to the like. So it's running in a server somewhere, not in my machine, not in your machine, right? And Fusion is just connecting to that machine.
On top of that, like we have more questions, but just a note. On top of that, Fusion served by the platform, it doesn't even require a real installation on the user's machine. It's just like, where do I grab my Fusion plugin? And that's it. So it's.
Is there any version control built into this?
You can use like your own. It doesn't. If you use your own like Git to like control your versions, like that's pretty much on you. Like we don't enforce in like the standalone mode. We don't enforce any. Version control system of our own. On the platform does have their. It's like it offers a Git server, so it does do version control on that, and you can select what version of the notebook you want to deploy to expose to your Excel users. We have more questions.
Does it only support Python notebooks?
Currently, yes, but there's nothing preventing it from supporting any other kernel. But that's where we started.
Yeah.
What sorts of things are they saying? Do they find it? Are they more likely? Do they find that this is an easier thing for them to actually use? Would they rather use this than actually learn Jupyter itself?
Yeah. So I think like the feedback we've been running on kind of like a free trial for now like for 6 months.
Yeah.
And we got over 8,000 downloads of Fusion. And the feedback that we got is like they felt very empowered, like from the business analyst perspective, and because it's an environment they're already familiar with, it's easy to get started, to understand Python, because they can see the results immediately in their Excel spreadsheet, right? So it also, from the Fusion notebook, you can open the notebook view, and then you can like start writing small code snippets. So it also kind of like self-empowers the business analyst to learn Python in an environment that they're comfortable, instead of like starting from scratch from a blank, Python script where they cannot see how the data is manipulated. Now they can see the results of those like Python functions, small code snippets in their Excel spreadsheet, and can start making those connections. So we got a lot of good feedback from the business analysts. The problem, or I wouldn't say that, but the challenge is that for this product to be successful, you kind of need both personas, right? You need like data scientists to start building notebooks that have the Fusion decorator to expose that functionality to business analysts. So right now we kind of have a set of 12 notebooks that come by default with Anaconda Fusion that kind of give you a sense of the possibilities. But now I think the chance more, how do we convincing data scientists that this is the right way to deploy for their business analysts, right? So they can start creating more interesting things. So it's kind of bringing the two teams together and seeing how they can collaborate, and then kind of seeing like the opportunities that exist in like from business analysts to start saying, hey, I would like to see this, and then like data scientists being very easily creating some script and like kind of like the back and forth between the two. But yeah, thank you.
I had another question first. Sorry.
Yes. Which versions of Excel do you support, and can data go from Excel into Fusion and back, or is it just from Fusion into Excel?
Yeah, so The limitations right now, it uses the Office 365 technology, so it's Excel 2016
Yes.
and above. So it's a limitation on the Excel side.
16 and above.
Yeah.
OS is Mac.
Both Windows
Yes.
and
Windows
Mac.
and Macs.
Yeah.
Yes.
Oh, and Mac.
Yeah.
Yeah.
And the data flow is
Both ways.
Both ways.
Yeah.
And it's async in both ways.
Yeah.
One of the limitations that the current previous technology had is always the synchronous of communications between processes and Excel. Fusion does not have that and leverages on the async nature of notebooks itself. Yep.
So after you output your data from your notebook into this spreadsheet, what's actually in those cells? Are those formulas that will automatically update and refresh from the notebook? Suppose I run a dual seek and my inputs are going into the notebook, outputs are coming into the spreadsheet. Will those values update?
So there's two kind of modes. So if you're just using the panel, there's like one of the, it's pretty hard to see, but one of the toggle bars there is called auto run. So that means every time you change something in the panel, the data it gets refreshed. So you can set that to like automatically to auto run. And then if you use the formula bar, we highlight the like a yellow bar, so then you can edit like the same way that you do formula. So there's
On that, one of the problems is you may have a function that is returning a larger set and it overlaps with the input from another function. So you have race conditions between your input and your output. So in that case, we block that. Like, and if your output is writing into an input area, we don't re-execute everything. Does it make sense?
So like an iterative calculation, for example, wouldn't work through this function call, like a circular calculation?
No, but yeah, no per se. But it may be an interesting case. Like it may be something that we can evaluate. Yes.
Is it possible for me to start like a notebook server on a Linux server while using Excel on my local PC machine? Is that possible?
Yep.
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 Also, what about the data transfer? If I have data that exists only on the Linux server, is it possible to load those data on a local PC through this platform?
One of the big wins of this approach is that you don't need to bring your data in. You can actually, you get your data from Excel, you only ship the data, the inputs that you need. All the computations, like that's the core of the Spark cluster example, right? The data is huge. You're not bringing that data to Excel. You're computing and doing your computation on the machine that has the data, so it's fast. And then you just bring in the results that you need.
It's all through the Jupyter notebook. So
Yes.
over there.
Question.
One is there any like mission type of thing, like you expose function, but anyone, so like anyone can connect that stuff, right? The other thing is any timetable, release timetable, and
So the first question was around permissions, and basically, yes, the platform version manages who can see what I share with others. The other question was about timetable.
release any product timetable.
Yeah, so the standalone version has already been released, and we've been running like a free trials, so people have been using that. And then like the enterprise version is being released in September, the one with the platform. Okay, I think we're out of time.
Yes.
Yeah. Okay.
Thank you.
Thank you very much.
Fabio.
Thank you.